Section 3.3, the unit circle and circular functions. Circular functions. A unit circle has its center at the origin and a radius of 1 unit. A unit circle means the radius is going to be equal to 1 unit, and that the center that will be in the origin. You could see that we do have the point x, y in the quadrant S here. And then we have the theta, and then the red one here, this is called arc of length, the S. How can we get x equal to cosine S and y equal to sine S? Let me show it to you guys. Okay, so we have a unit circle, and then this time let me put the point xy into here. Okay, this is a right triangle, and we know r is going to be equal to 1. Okay, xy at this point, so means this length is going to be x, this length is going to be equal to y. So we have cosine theta equal to x over r. Okay, and since my r is equal to 1, so cosine theta is going to be equal to x. Same idea for the y here. I will have a sine theta equal to y over r. And r is going to be equal to 1, so we have a sine theta equal to y. Okay, and then we're going to call this line the point xy until the x-axis here. This is the arc length. We call this as equal to s. And then s, that will be equal to r theta. Since my r is going to be equal to 1, so s, that will be equal to theta. And that's why I have these two equations. And then I'm going to plug it in, x equal to cosine s and y equal to sine s. And that's why we do have these two guys in here. Okay, one more time. The xy, I could revise it to cosine s, comma, sine s. Okay, talking about at this point. This is applied when r is going to be equal to 1. Okay, and we call this is the unit circle. The trigonometric functions of angle theta in radians found by choosing a point xy on the unit circle can be written as the function of the arc length s, a real number. Okay, we could write it x equal to cosine s, y equal to sine s. When interpreted this way, they are called circular functions. For any real number s represented by direct arc on the unit circle, y equal to sine s. Cosine s is equal to x. How about the tangent? What is the tangent s equal to? Tangent will be equal to sine over cosine, right? So that will be y over x, given that x cannot be equal to 0. Okay, we also have a cosecant. Cosecant is going to be the reciprocal of sine, which is going to be 1 over y. How about secant? Secant s will be 1 over x. And then we have a cotangent x, that will be x over y. The unit circle. We talked about this unit circle in the previous session, right? I need you guys remember all the degrees in radian also, and also for each point in here. Okay, pretty much if you remember the special triangle, the 30-60 and the 45-45, you should remember all this coordinate. The unit circle is symmetric with respect to the x-axis, the y-axis, and the origin. If a point A, B lies on the unit circle, so do A negative B, negative AB, and negative A negative B. You could think about like pi over 6, this guy here. Okay, we have the coordinate, roughly over 2 and 1/2. So we could look at the 150. Okay, since the angle 150, the reference angle is also equal to 30. So you could see they do have the same coordinate here. It just x would be negative because in the quadrant 2, x is negative, y still positive. You also can look at the 210. The reference angle of the 210 is also equal to 30. Okay, so they share the same coordinate, they just have the different sign here. So x and y in this quadrant will be negative. And the last one, 330. The reference angle of 330 will be 30 again. Okay, so we do have the same coordinate, 3 over 2, and the y will be negative, so negative 1/2. So I just use the pi over 6, which is 30 degrees, right? And then we say they do have the same coordinate, they just have a different sign here. And this is the example for 60 degrees, pi over 3. Okay, pi over 3, you're gonna get 1/2 and 3 over 2. That's a quadrant 1. Okay, and then 2 pi over 3, which is gonna be 150. So they do have the same reference angle and they do have the same coordinate here. It's just like the different side. Quadrant 2, the x will be negative, y will be positive. Write it down, cosine s, that's talking about the coordinate of x, will be equal to 1/2. Sine s will be the coordinate of y, which is 3 over 2 here. And since this is a unit circle, okay, we have the equation of the circle, x squared plus y squared equal to 1. Talking about the center is on 0, 0, and radius is going to be equal to 1. Now, we know x is equal to cosine s, and y equal to sine s. You could plug it in. You can prove the identity. Okay, cosine squared x plus sine squared x equal to 1. Domains of the circular functions, sine and cosine functions from negative infinity to positive infinity. We don't have any restriction for the domain in here. But how about tangent and secant functions? We do have the domain as cannot be equal to 2n plus 1 times pi over 2, where n is an integer. So think about it. Let's say n is equal to 0. So s cannot be equal to pi over 2. Okay, s cannot be equal to pi over 2. You could look at the unit circle here, the tangent and the secant. When s equal to pi over 2, talking about like this point, okay, this is the s equal to pi over 2, what would happen for the tangent? Tangent, that is equal to y over x. Okay, y over x. That means 1 over 0, that will be equal to undefined. So that's why they say tangent cannot be equal to 90 degrees, because when tangent at this point, that will be equal to undefined. Same idea for the secant. Secant means the reciprocal of cosine. Okay, reciprocal of cosine means 1 over 0. So secant at pi over 2 is also equal to undefined. When n is equal to 1, we will have a 3 pi over 2, means like 270. Same idea, at the 270, tangent and secant is also equal to undefined. Cotangent and cosecant functions. The s cannot be equal to n pi. So s cannot be equal to 1 pi, 2 pi, 3 pi, 4 pi. So this is talking about all the 0 and 180, 360, and you keep going on it. Cotangent and cosecant will be equal to undefined at this point. Okay, so that's the domain here. Evaluating a circular functions. Circular function values of real numbers are obtained in the same manner as trigonometric function values of angles measured in radians. You could look at the unit circle. You do have the same idea from the previous sessions, how we get the trigonometric functions. Like sine equal to y over r, cosine equal to x over r. Okay, they are talking about the same thing when you look at the unit circles here. Example 1. Find the exact values of sine 3 pi over 2, cosine 3 pi over 2, and tangent 3 pi over 2. So first, sine 3 pi over 2. 3 pi over 2 talking about the data from here to here. And it also equivalent the s here, 3 pi over 2. And then at the angle 3 pi over 2 that intersect this coordinate 0 and -1. And remember that x, the coordinate of x, that will be equal to cosine s. And then the coordinate of y, that will be equal to sine s here. Okay, right? And then the tangent will be y over x. Now, what is the coordinate of y here? That's a -1, right? So we know that sine 3 pi over 2, that will be equal to -1. Same idea for the cosine. Cosine 3 pi over 2, that will be equal to the coordinate of x, which is going to be equal to 0. And then tangent, that will be y over x. So that will be -1 over 0. And remember that this is undefined, because the domain of the tangent cannot be equal to 270. Example 2. Use the figure to find the exact values of cosine 7 pi over 4 and sine 7 pi over 4. 7 pi over 4, that will be here. Okay, at this degree here. Cosine 7 pi over 4, that will be equal to the x, which is going to be rectangle over 2. And then sine 7 pi over 4, we're going to look at the coordinate of y, which is negative rectangle over 2. Okay, how about tangent -5 pi over 3? Okay, I want you guys try to do it by yourself and make sure that negative means you're going to go clockwise. Okay, go on like this direction for 5 pi over 3. Okay, so 5 pi over 3 is supposed to from quadrant 1 go to the quadrant 4. But now, since this is a negative, so we're going on different directions, going backward like this way. Okay, and then we could use the 2 pi minus 5 pi over 3. Get the same denominator, so that will be 6 pi over 3, which is pi over 3. So that will be here. So with the angle -5 pi over 3, we will have the coordinate 1/2 and rectangle over 2. Okay, and tangent -5 pi over 3, that will be equal to the reference angle, which is going to be pi over 3. And the tangent in first quadrant, that's a positive. Okay, and then tangent, talking about y over x. So we do have a rectangle over 2 over 1/2. Simplify it, you're going to get rectangle. Okay, C. Use reference angle and radian to degree conversion to find the exact value of cosine 2 pi over 3. So first, we're gonna convert the radian to degree. Okay, 2 pi over 3 convert to radian. So you're gonna times 180 over pi. You should get 120. Okay, and then 120 will be on the quadrant 2, and the reference angle will be 60. Okay, but quadrant 2 for cosine, that will be negative, so equal to negative cosine 60. Negative cosine 60, that will be equal to 1/2. Okay, example 3. Find a calculator approximation for each circular function value. Cosine 1.85. Remember when they didn't specify they're using the degree or radian, you're gonna consider this is gonna be the radians. So make sure change your calculator from degree to radian. You should get negative 0.27559. Okay, so approximate negative 0.2756. Okay, cosine 0.5149, that will be 0.8703. So 4 decimal space, so strictly equal to 0.8703. Okay, try these two examples, cotangent and the secant. Okay, check your work. You're gonna use 1 over tangent, right? You don't have a cotangent on your calculator. And this guy, that will be 1 over cosine. So you should get this one. Caution, common error is using a calculator in degree mode when radian mode should be used. So make sure you need to know, are you using the degree or radian on your calculator, okay? Approximates the value of s in the interval 0 pi over 2 if cosine s equal to 0.9685. So we consider s will be in the first quadrant, so from 0 to 90 degree. Okay, so we need to find the inverse of cosine, this number. Okay, you're gonna get 0.2517. Find the exact value of s in the interval from pi to 3 pi over 2 if tangent s equal to 1. Okay, think about it. Tangent s equal to 1. Tangent what angle will be equal to 1? You will have 45 degree, right? Tangent 45 degree should be equal to 1. So the s should be equal to pi over 4. Okay, they given the radian, so we're going to use the radian. So tangent pi over 4 should be equal to 1. But pi over 4, that is a reference angle. And then we want the s will be in quadrant 3. So the s should be pi plus pi over 4. Which is going to be 5 pi over 4. Example 5. Find the exact values of s in the given interval that satisfy the given condition. We have a cosine s equal to √3 over 2. And the s will be inside the interval from pi to 2 pi. So let's do it together. So we have cosine s equal to √3 over 2. And then the interval, from pi to 2 pi. Okay, before that, we're going to draw the special triangle. We have a 30, 60, and then we have a 45, 45. Okay, and then the interval, that will be in between pi to 2 pi. Okay, so the angle should be located from here. And then we're going to look at it. Cosine s equal to rad phi over 2. So rad phi over 2, that would be 30 degrees. However, the given interval is in radian, so we want to use the radians. So first, we're going to write down the reference angle. That will be pi over 6, which is going to be 30 degrees. So now we're going to think about it. Cosine s is equal to positive rad phi over 2. Okay, and then the angle is only in quadrant 3 and quadrant 4. So quadrant 4 in here, that will be positive for cosine. Okay, remember the CAST, right? CAST. So for these two quadrants, cosine will be on quadrant 4, that's a positive. And then now we find the reference angle, which is going to be pi over 6. So reference angle here, pi over 6. So now we're going to write it down. The angle S, that will be 2 pi minus the reference angle. Get the same denominator. So we do have 11 pi over 6. Okay, check the work. Reference angle, find out the reference angle. If they're given in the radian, you have to use the radian. And then cosine is positive in the quadrant 4. So we have a 2 pi minus reference angle, which is going to be 11 pi over 6. Okay, next one. B, cosine square s equal to 1/2. And this time, that will be from 0 to 2 pi. Okay, let's do it together. Okay, cosine square s equal to 1/2. And that will be from 0 to 2 pi. Okay, it means you're gonna take all the quadrants. So we do have a cosine square s. We're gonna take the square root for both sides. Once you take the square root, you have the plus minus. Okay, right? So if I write one more step, it should be 1 over rad 2. So look at the special triangle. 1 over rad 2, that will be 45 degrees. Again, we will be using the radian because the given interval is radians. So we're going to write down the reference angle. That will be pi over 4. Okay, and then since the s will be within this 4 quadrant, so we're gonna do it like one by one because we have a plus minus. So think about it. For the quadrant 1, the reference angle is gonna be here. Okay, so we do have the first one, quadrant 1, angle will be pi over 4. Okay, this is talking about when cosine s equal to positive 1 over rad 2. Okay, so positive here for cosine. And then we have the quadrant 4. Okay, reference angle is going to be here, pi over 4. So for quadrant 4, the angle S will be, we're going to calculate it, start it from the 0 until this point. So talking about like from here to here. So 2 pi minus pi over 4. Get the same denominator times 4. So 8 pi minus pi, that would be 7 pi over 4. Okay, right? And then when S is going to be negative, when cosine S equal to negative 1 over rad 2, This is talking about quadrant 2 and quadrant 3. So quadrant 2, when the reference angle is here, pi over 4, we're going to calculate from here. So that will be pi minus pi over 4, which is going to be 3 pi over 4. And then when s is a negative, talking about in quadrant 3. Okay, I'm going to use a different color here. Okay, reference angle will be here, pi over 4. So we're calculating the angle from here until here, which is going to be pi plus pi over 4. That will be 5 pi over 4. Okay, one more time, since we do have the square, when we take the square root for both sides, we're going to add plus minus. And cosine with the plus minus means we're going to take all the quadrant 1, 2, 3, 4. After you finding the reference angle, you're going to calculate for each quadrant one by one. Okay, so your work here. I try to rationalize. If you could notice that 1 over rad 2, that is a 45 degree, you don't have to do the rationalize here. Okay, s in the range from 2 to 2 pi, we need to find the s in quadrant 1, 2, 3, 4. So we're going to do it like one by one here. Okay, see, I want you guys trying to do it by yourself. Okay, we have tangent s square s equal to 3. And that would be from 0 to 2 pi again. We're going to take the square root for both sides. So we have a plus minus square root 3. And then look at the triangle, tangent s equal to rad 3 over 1. So that will be 60 degree. So reference angle will be pi over 3. And one more time, plus minus, you're going to take all the quadrant 1, 2, 3, 4. So in the quadrant 1, reference angle, that will be pi over 3. So s equal to pi over 3. And then quadrant 2, pi over 3 will be here. So we're going to calculate it from here to here. So s equal to pi minus pi over 3, which is going to be 2 pi over 3. And then quadrant 3 will be here. So that will be starting from 0 until here. So s will be pi plus pi over 3, which is going to be 4 pi over 3. And then last quadrant 4, that will be here. So s will be 2 pi minus pi over 3. So that will be 5 pi over 3. Okay, so you do have a 4 answer: pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, check your work. Okay, last one. This one's a sine square s equal to 3 over 4. And the s will be in the interval from negative pi to pi. Okay, from negative pi to pi. Okay, let's do together. Sine square s equal to 3 over 4. And that will be from negative pi to pi. Okay, what is like negative pi to pi? Does this the same thing? Is it equal to from 0 to 2 pi? No, they are not equal to each other. Okay, 0 to 2 pi is starting from 0 until the 2 pi. And then you also see the bracket is equal to 0. Okay, this is a parenthesis to 2 pi. Negative pi to pi is talking about negative pi, negative. You're going clockwise. So starting from here till here. This is a negative pi. And then 0 to pi again. You're going to go back. Okay, so that's a little bit different from here. So what we're going to do, we are looking for from negative pi to pi. Let me separate it. I could break it down to negative pi to 0 and from 0 to pi. Okay, we're going to separate into two parts. The first part from negative pi to 0. Second part from 0 to pi. So now let's take care of this part. Okay, we calculate this guy. You should have sine s equal to plus minus square root 3 over 2. Okay, take the square root of 4, which is going to be 2. And then when you take the square root for both sides, you're going to add plus minus here. And this part, we only focus from 0 to pi. Okay, from 0 to pi, this is talking about the quadrant 1 and quadrant 2. So the reference angle, we're 3 over 2, which is going to be sine, so that'll be 60. So pi over 3. Okay, quadrant 1, that will be here. So just s equal to pi over 3. And then quadrant 2, talking about like here, right? So we have pi minus pi over 3, which is going to be 2 pi over 3. So we are good on this part. Now we're going to focus on here. Okay, we're going to do the same thing. We have a sine s equal to plus minus 3 over 2. And now we're going to focus on this region. Same idea, the reference angle still pi over 3. Okay. Now we're going to look at it. Quadrant 3 and quadrant 4. Okay, but we are going on clockwise. Okay, we are going like this way. So think about it. For quadrant 3, when we're going clockwise, we do have a negative pi. Okay, negative pi. And then we have the reference angle here. Reference angle pi over 3. And this is going to be negative 5. So we try to calculate the angle starting from here to here, which is going to be negative something. So for the quadrant 3, we have a negative pi plus pi over 3. So you should get negative 2 pi over 3. Okay, so talking about the black one here, this is negative 2 pi over 3. And then quadrant 4, Quadrant 4. So again, we're going clockwise. So talking about like here. And this is going to be equal to your reference angle, which is going to be pi over 3. So negative pi over 3 here. Okay, so you do have 4 answers. First one, second one, third one, and then the fourth one. Make sure you say s equal to. Okay, s equal to negative pi over 3 here. Okay, check your work. So we only take care from 0 to pi. So quadrant 1 and quadrant 2. Okay, right? And then second part, we're gonna take care of negative pi to 0. Okay, so quadrant 3, going clockwise to the pi. So negative 5 plus the reference angle, negative 2 pi over 3. Quadrant 4, that will be negative pi over 3. Okay, that's it.